evaluating limits algebraically continued here. We're still trying to determine the limit of functions algebraically, and we've talked about factoring. So today we're going to look at conjugate multiplication, complex fractions, and trig identities. Okay, so these are when if you just substitute the value, you're probably going to get dividing by 0 or something that doesn't work, so we have to use other algebra techniques to find the limit. All right, so for conjugate multiplication, you're going to multiply by the conjugate to simplify, and then you're going to substitute in the value, okay? And so the conjugate, you'll see with example 7, is really just the square root, whether it's the numerator or the denominator, the square root term with the opposite sign in the middle. So for example 7, the conjugate of square root of x minus 2 would be the square root of x plus 2. Okay, so let's do that with example 7. We're going to multiply the numerator and the denominator by the conjugate, which is the square root of x plus 2. Basically, so when you FOIL or distribute to everything, your square roots on the numerator go away. Okay, so now we do have to FOIL this, okay, the top and the bottom. All right, so when you do that, now we're at the limit as x approaches 4. The numerator, when you FOIL it out, will be x minus 4, okay, because your middle terms will cancel. You can do this on the side if you need to. And then the denominator, if you're not FOILing there, you can just write it and we can do it together. So x square root of x plus 2 times x minus 4. If you just leave it like that for now, don't do the denominator out, and hopefully you're seeing why. Okay, because the x minus 4s will cancel. All right, so those x minus 4s, those binomials on the top and the bottom cancel each other out. So then you're left with the limit as x approaches 4 of 1 over the square root of x plus 2. Okay, and now that we've simplified, we're just going to substitute 4 in. Okay, so that would be the square root of 4 plus 2, and that would give me 2 plus 2 on the bottom, which is 4. Okay, so that limit there is 1/4. So we use conjugate multiplication to simplify, binomials canceled out. All right, and then we get substitution to find our answer. Okay, let's try another one. So example 8, same idea there. The conjugate here would be the square root of x minus 6 plus 2. Okay, so you're really just taking the opposite of that middle sign, whatever's between the square root and the number that's outside the square root. Okay, that's what a conjugate is. So if we multiply here, we're multiplying by the square root of x minus 6 plus 2 on the numerator and the denominator. Okay, and again, you don't really want to FOIL out the denominator. Something should cancel. Okay, so but when you FOIL the numerator, you're getting x minus 6, and then your last term would be minus 4. Your middle term should cancel. Okay, so now we're at the limit as x approaches 10 of x minus 6 minus 4 all over x minus 10 times square root of x minus 6 plus 2. Okay, and as you can see, when you do x minus 6 minus 4, that is x minus 10. Okay, so those two binomials are going to cancel each other out, just like last time, and you're left with 1 on top. All right, so let me rewrite this, and then we're going to substitute 10 in. All right, so this would equal the limit as x approaches 10 of 1 over square root of x minus 6 plus 2. And let's go ahead and substitute 10 in. So this would equal 1 over square root of 10 minus 6 plus 2. The square root of 10 minus 6 is square root of 4. So this actually ends up being same answer as last time. 1 over 2 plus 2 is 1 over 4. Okay? All right. We have a couple of examples there. Why don't you pause the video and try example 9 and 10, and I will write the answer for you. And if you still don't understand how to get that, you can ask for help in class. All right, so pause that right now and try 9 and 10. So for 9, you should get negative 1 over 16. Oh, excuse me. Whoops, not looking at the right one. Okay, so for 9 and 10, we'll just go over those in class. I don't have them done out yet. My bad. All right.